All right, but like I said last week, I'm going to jump straight into it. We have spoken about how to prepare for exams, how to get ready for exams. I don't think I need to go through that again. The recording link, excuse me, is on Google Classroom, so you can have a look there. But essentially, it's there for you. Go, do, explore. So we're just going to jump into it. So Sunday, hear you, Euclidean. We will be English is not English in today. We will be doing Euclidean next week as one of our big focuses. So next week, Saturday, we're going to focus on Euclidean and trig. Stats and analytical is obviously in paper 2 as well, but Euclidean and trig together counts about 90 of your 150 marks. And so obviously I should be able to do that in my head, but I can't. So we're just going to pretend that's 60%, if I'm not mistaken, of your paper is Euclidean and trigonometry, which means that we're gonna spend time on it. Okay, we're gonna go through how to approach those questions, etc., etc. And once again, in Euclidean, the bulk are circles. Obviously, we do bring in proportionality and similarity, but the bulk of your Euclidean is circle geometry, which is grade 11. Okay, so we are going to deal with it next week, so get ready. Right, guys, but we're jumping straight into it. We are going to hopefully today have a look at functions and sequences and series. Functions because, okay, now I'm going to go through everything. No. Functions because, sorry, why on earth would I have everything in a place that's convenient for me? Because it is the biggest section in your paper along with calculus. And because we're currently doing calculus in class and all of you are with me in class, we're doing that right now. So we're kind of revising it as we go along through the teaching. And then, like I say, functions and graphs, next biggest section in your paper. And then sequences and series. We've done the algebra. So that's the next biggest section. Sequences and series, next biggest section. Finance, counting principle, probability, those are your smaller sections. So essentially, we would have done 120 of the 150 marks through revision of these things, which is, again, I know I should know, but I don't, 80% of the paper. Okay. Right, so like I was saying now, when it comes to your functions questions in your exams, generally speaking, the functions questions start off with, I haven't put one here, but generally start off with question 3, question 4, and we start off usually with a nice easy hyperbola. Oftentimes it's a hyperbola, not necessarily always, but often, where we ask for, where's the asymptote? Where's the x-intercept? Very straightforward, maybe sketch the hyperbola, but that's it. We then move on into our next question, which is usually question 4 or 5, where it is a combination of graphs, so like what we have here, and then we have our inverse function in the next question. So we're going to start off by looking at our combination type question. It involves a lot of graph interpretation on our part, and we're going to hopefully get through, understand what's happening here. All right, so first we assess what information we've been given. And now grade 12s, this is really important when it comes to exams, and then you said when it comes to graphs. When it comes to exams, we need to be able to read the question properly. So, and granted, I'm fully aware of the fact that you are not grade 8s, but my grade 8s had a test the other day where it very clearly said to them, write your answers on a certain part of the exam paper. And probably half the class was like, ma'am, I don't know what to do. Where am I supposed to do this? And it's just because we're not reading the question. I think we associate maths with not necessarily needing to read the question properly, particularly ones where there's a diagram attached. So a Sunday, like Euclidean geometry, we don't read those questions properly. We just go straight to the diagram. And so what that means is we're often missing information. So it says below the graphs of f of x equals x squared plus bx minus 3, and g of x is equal to a of x plus p. So we've been given two functions. One is f of x, which is your hyperbola. And so again, like you have a question paper, you are able to do whatever you want with the question paper. If you need to highlight your graph, do it. So there's my f of x graph. It's not the best highlighting job I've ever done in my life, but there we go. And then we've got g of x, which is my hyperbola. So there's my g of x graph. We're just going to pretend that was good enough. And we can also very clearly see the asymptote there at positive 1. So that's going to help me in a second. It says that f has a turning point at point C, it down the bottom there, and passes through the x-axis at 1, 0. So it's English. One of the x-intercepts of the parabola is the asymptote of my hyperbola. D, there we go, is the y-intercept of both the hyperbola and the parabola. The graphs also intersect each other at E and at J. The vertical asymptote of G passes through the x-intercept of F, which is what I just said. Okay, I'm going to take all of these scribbles off just because it's a lot. But reading the information of our question, very, very important, so that we do actually know what we're working with. Okay, we now have a bunch of information there that is going to be useful to us in answering certain questions. And as much as most of it can be seen on the diagram, every now and then we slip a piece of information into the written information that's not on the graph. So the first question is asking us to write down the value of P. So P is in the denominator of my hyperbola. Does anyone remember what that would represent on my graph? So I'm not asking it what is the value of P. What does it represent on my function? Nice, Callan, very good. Okay, so guys, it represents my vertical shift. It represents the shift left or right, and it's the one that's counterintuitive. So if it said x plus 2, it's actually shifting 2 units to the left. If it said x minus 3, it's actually shifting 3 units to the right. Now, because we were told where the asymptote of this function is, we can see exactly where that p-value is going to be. So we know that it shifted 1 unit to the right. And so we know that this expression, my denominator, should read x minus 1, because that represents 1 unit to the right. Now, this is often where it's a very easy question, but you get caught out, you overthink it. Because it's x plus p, because I know my expression must read x minus 1, that means my p-value needs to be -1, because when I substitute that in, the positive and the negative when multiplied together give me the -1 that I'm looking for. So don't make a silly mistake with the sign. Like I said, it's often where you get caught out, and it's an easy question. It's 1 marker, but don't get caught out because of a silly sign situation. Right, question 4.2 says, show that A equals 3 and B equals 2. Now, really importantly, we're told whenever you get a question that says, show that, you may not use the values that you were given. So you may not use A equals 3 and B equals 2 at all in your calculations. If we go and look first where A and B actually are, we're talking about the variables in the equations. So B is part of f of x, A is part of g of x. Don't get confused, and as much as it isn't on the graph, don't get confused between a lowercase b and an uppercase b. So what I mean by that is, and usually we don't do it, but I'm just warning you. Let's say, for example, this coordinate I'd labeled as B. That is a capital B. This is a lowercase b. Don't get confused between the two of them. Like I said, we generally try not to label capital lowercase just because of the fact that it can get confusing. But if for whatever reason there is one, just bear that in mind. All right, so show that. What this essentially is asking me to do is find the missing value. And we don't want to at any point use those in our calculations. That should essentially be our final answer. It doesn't really matter where you want to start, okay? But we need to try and have as much information as possible for us to go and determine these unknown values. So I'm going to go back to my graph and just figure out what information do I have that isn't necessarily on the drawing. Obviously, we know that this x-intercept is at 1, 0. And we were told that the coordinate of D is the y-intercept of both functions. Now, when we want to determine a y-intercept, this is when we make x equals 0. But if our quadratic, so the parabola, is in its standard form ax squared plus bx plus c, we know that the c value is the y-intercept. And so what we know is that this coordinate of D is actually at 0, -3. So we actually have two pieces of information on my parabola. I also have another piece of information on my hyperbola in the D value, or the D's coordinate. And exactly as the scientist said, that we do have an x-intercept of our parabola. So this is information that we're going to use. We don't give you information unnecessarily. Remember that, Gretols. If it's there, it's because I want you to use it. So based on what we have, what can we do to go and find, and generally if you get confused, start with A. So let's start with A. How can I go and find the coordinate of A? Obviously, currently I found the value of P. So all I have, or what I have of my equation is A over X minus 1. How can I go and find A based on the information we know we have? Nice, Callan. Okay, so guys, generally speaking, if there is one unknown that you don't have, get a coordinate that's on the graph and substitute it in. So I want you to quickly substitute in the coordinate of D, 0, negative 3, and find for me the value of A. Hopefully, it's going to be 3, but let's find that value of A quickly. I'm going to give you like a minute. You don't need long for this. Excuse me. All right, and then you can just let me know if you do agree with A equals 3. Nice. Okay. So we sub in, negative 3 as my y value is equal to A over 0 minus 1. This gives me negative 3 is equal to negative A. And so yes, indeed, A is equal to 3. Nice and easy. I now have the equation of g of x. I know this is 3 in the numerator. It's already useful to me right now. Okay. Now I have to go and find the value of b. So what we know of f of x is not really anything more. X squared plus bx minus 3. Essentially, this means that the coefficient of x squared is 1, and obviously my c value here is negative 3. I don't need to write any of that down, but just bear it in mind. You don't have to go work any of that out. It's been given to you. We just need to find the value of b. So again, how are we going to find the value of b?
We sub in
What are we going to sub in?
the value of A,
Value of a.
which is 3, because that formula in its standard form is was ax to the power of 2, or is that wrong?
No, I hear where you're going with this, but just be careful. I already know that this coefficient here is 1. I've given that to you. Because I haven't written a variable a in front of the x squared, it means that I'm actually giving you that a is equal to 1. So I like what you're thinking in terms of the substitution, but just be careful. If I don't put a variable in front of the x squared, you know it's positive 1. So Butley is on the right track there. Substitution. What are we substituting in? Nice, Callan. Okay, so we're going to have to substitute in the x-intercept. Now, importantly, guys, we don't substitute in the y-intercept, and let's just think about this logically. If we substituted in the y-intercept, we'd be substituting x equals 0. And if we have x equals 0, we would have b times 0, which is 0. And so essentially, we're actually canceling out the b, which is what we're trying to solve. So we don't want to substitute in a point that gets rid of the variable. If I substitute in my x-intercept, which is at 1, 0, I then have 0 is equal to 1 squared. I should put it in brackets, but I didn't. Plus b times 1 minus 3. And I can solve for b. So, sorry, my brain. 0 is equal to b minus 2. And so b is equal to positive 2. And so now I have the two unknowns in each of my equations. So now I know that g of x, and I always like to write my equation out, I just find it quite helpful, is 3 over x minus 1. And f of x is equal to x squared plus 2x minus 3. And if I need to use anything here, I now at least have my equation. All right, so just be careful in terms of the things that I've mentioned. We know the coefficient of x squared that's given to us only if there's a variable there. Do I not know? And we don't want to substitute something in that's going to eliminate the variable I'm trying to solve for. Right, obviously marks here, sorry guys, as I remember mark allocations, I'll do them. Obviously first question is just -1. In terms of your second question, in terms of finding a and b, you're doing the same method for both questions. So you're doing a substitution and you are finding your value. So we are going to give you a mark for getting your coordinates of D and understanding to substitute that in. So even though I haven't written down my coordinates of D, I can clearly see that that's what I've substituted in. So D's coordinates and then a mark for substituting. And then on the other side, a mark for substituting in 1, 0. Notice how you don't get a mark for A equals 3 and B equals 2. And that's because I kind of already gave them to you. I told you that's what they were. I just asked you to show me that that was true. So we're not going to give you a mark for something we have given you. With that being said, grade 12s, if you can't answer 4.2, please make sure that you do actually then use A equals 3 and B equals 2 in your later calculations. They are true. And so if you couldn't get those 3 marks here, when you now go to 4.3, you do actually have the complete equations for each of your functions. So we do know f of x and we do know g of x, even if you weren't able to solve it in the previous question. Right, but 4.3 does now ask for the coordinates of C. What is C? Like, what's special about it on my graph?
The turning point of the parabola.
Okay, awesome. So this is our turning point. So I'm going to ask you to do it by yourselves. There are lots of different ways that you can now find the turning point. Grade 12s, we have many tools in our toolkit. We can complete the square. We can find the first derivative because we know that finding the first derivative and making it equal to 0 is a stationary point or a turning point. We can also, if we want, I've said completing the square, we can also, if we want, use a little formula that the x coordinate of a turning point is minus b over 2a. Any of those are perfectly valid. Okay, I'm assuming most of you probably won't choose completing the square and probably one of the other two, but any of those 3 is going to get you the coordinates of C. So 4 marks, I'm going to give you 4 minutes. I want the coordinates of C, please. Coordinates means x and y. All right, remember, if you get stuck at any point, just ask Helen. I like where you're going. I know you said sorry because I know you've recognized that we haven't finished, but you're on the right track, which is awesome. Right, those of you that are done, awesome. Can you tell me which method you used? So did you complete the square? Did you find the derivative? Did you use the minus b over 2a? Okay, nice. All right, and Butler's made a good point there, is that once we have our x value, we need to substitute that back into our f of x to find the y. Now, I'm going to show you all three, mostly because realistically, completing the square is actually the most useful because it gives us x and y without needing to do any substitution. But I also understand that completing the square is not everyone's favorite. All right, so we now have f of x squared plus 2x minus 3. And just like to prove the point of completing the square is not everyone's favorite, this memo didn't even show completing the square as an option. It is an option, and it's fine, but it didn't even show it. All right, so I'm going to use the method you guys use. X coordinate of our turning point would be minus b, so 2, all over 2 times 1, which is a. So negative 2 divided by 2 is negative 1. We then substitute that into our original equation, so negative 1 squared plus 2 times negative 1 minus 3, and we get negative 4. So C's coordinates are negative 1, negative 4. No issues there, perfect, that's it. Okay, second option is derivative. So if I find my first derivative, that would be 2x plus 2. I know that I can, let's do this. I know that to find the stationary point or the turning point, we make that equal to 0. And we get 2x is equal to negative 2. And so x is once again equal to negative 1. And then we do the same thing as what we did here. We substitute into f of x, and we get the same coordinate. So that is using your derivative. If you wanted to complete the square, again, I know this is probably the method no one would use, but like I said, it actually gives us all the information straight away without the substitution. Excuse me. So if I want to complete the square, what I do is I take my first two terms and I write it as a bracket squared. So to get x squared, I would have to say x times x. And then to get my constant term, I take that b value, so plus 2, and I divide it by I divide it by 2. So I get plus 1. I still have a minus 3 there, but what I need to remember is that if I were to distribute out this bracket x squared plus 1, I would get x plus 1 squared. I would get x squared plus 2x, which are those first two terms there. But then I also have a plus 1. So I need to remember to minus 1 as well to keep the whole thing still meaning or representing f of x. So this is x plus 1 squared minus 4. And now we have the turning point. So remember, it's counterintuitive. Plus 1 actually means that my graph has shifted 1 unit to the left. So that would mean C is at negative 1. And then I have my y value at negative 4. So completing the square gives us both values at the same time. Tells again, I'm fully aware that no one likes completing the square. It's absolutely fine. You don't have to use it. I'm just showing you so that you have all of the available methods there for you. Okay, we will mark all 3 of them. You will get 4 marks. So just that you are aware of where your marks come from the first one, substituting into your minus b over 2a, getting x is equal to negative 1, substitution into f of x, getting the negative 4. If you went derivative, the expression for the derivative, and making it equal to 0, getting your x equals negative 1, and then your last 2 marks are the same as what happened here. If you completed the square, although the mark allocation isn't actually on the memo, I'm just going to kind of tell you what it would be. So you get a mark for the x plus 1 squared for subtracting the negative 1, and then you'd get a mark for your x and your y. Again, not many people use it, but there it is. That's how we would do it. Any questions? Are we all good? I'm going to assume that if you do have a question, you're going to ask. You're pretty good with that. Nice. Right, so 4.4 says write down the range of f. Can someone just remind me, what is range?
Y values.
Right, so it's all my y values where my graph exists. And f is my parabola, which means I'm particularly looking at, no, those words are wrong. I'm particularly looking at the graph in relation to its turning point, because obviously, or hopefully we agree, my graph doesn't exist anywhere below my turning point. Okay, that turning point is its cutoff. So there's nothing below that, which means all of my graph exists above my turning point. And because we now know this turning point is at negative 1, negative 4, I know that my range is every y value greater than or equal to -4. Now, we have to include the -4 because we do actually have the turning point at -4. It's still on my graph. If you want to write it in interval notation, you can. I don't like interval notation, but you obviously are more than welcome to. Y is an element of. We're going from -4, the lowest value, which is included, all the way up to positive infinity. And because I don't know where infinity ends, I use a round bracket. I prefer an inequality. That is always how I will write down my answer. But obviously, if you use interval notation, it's absolutely fine. The only thing I am going to say here, grade 12s, is please make sure you use the correct either brackets or inequality sign. These marks are often 2 or nothing marks, or however or nothing marks. Okay, and we did discuss this in the algebra section with the quadratic inequality. If you put the wrong brackets in, you're going to lose marks. If you put your inequality sign the wrong way, you're going to get 0. So it's really important that when you do actually write it down, you are writing it down correctly. All right, we have a few more questions here. So let's not screenshot just yet. Let's have a look at 4.5. So 4.5 says determine the equation of the line through C that makes an angle 45 degrees with a positive x-axis. Write your answer in the form y equals. So again, let's just break this down for ourselves. We're looking for a straight line through this coordinate C, okay? And it makes an angle 45 degrees. Now, importantly here, grade 12s, 45 degrees is an acute angle. So if I were to draw this line, hopefully we remember from angle of inclination that this means that it has a positive gradient. So there is my angle of 45 degrees with the x-axis. If I'd said it makes an angle, let's say, for example, of 135, that is then an obtuse angle, which means that we know our straight line has a negative gradient. And this is now taking us back to our analytical geometry. Now, even though analytical geometry is a paper 2 topic, we can bring it into paper 1, and often we do so in functions like in this question. So there's my straight line that I'm looking at, and let's actually just make it a little bit bolder because, or not, whatever, that's cool too. While I'm struggling with technology, could anyone tell me what the gradient would be for a straight line that has an angle of inclination of 45? I'm not going to fight with it. I don't think it's worth my time. What would the gradient be? So if my angle of inclination theta is 45, what is m? Bootle, what's up? I'm assuming this is just absolute shock. We don't remember angle of inclination. Nice Sunday. Okay, so quick recap. Remember, the angle of inclination is the angle measured from your positive x-axis to a straight line, wherever that straight line is. And the formula for the angle of inclination is tan theta is equal to m. Now, we've been given theta. So we know that tan 45 would be equal to our gradient. And so if we just type tan 45 into our calculator, we know we have a gradient of 1. And so what this now means is that we know y is equal to 1x, which obviously we won't write the 1 there, but I'm going to for now, plus c, and we now need to find the y-intercept. We know that it passes through the coordinate of c, so I'm going to substitute in c's coordinate of -1, -4, which means I've got -4 is equal to x, is equal to -1 plus c. And so I get that my c coordinate is at -3. And so I have the straight lines equation, y is equal to x minus 3. All right, so like I said, unfortunately, fortunately, I don't really know. We can bring paper 2 concepts into paper 1, same as we can bring paper 1 concepts into paper 2. One that pops up every now and then in paper 2 is sequences and series in trigonometry. So often what we do is like a problem-solving question, and this could also actually come into paper 1 as a problem-solving question for sequences and series, is we give you a sequence that's made up of trigonometric ratios that are cofunctions, and you have to recognize the cofunctions and go from there. Now, obviously, that's problem solving. We're not going to stress about that right now. As we said, the bulk of our paper is knowledge and routine questions. But the reality is we can bring in, okay? So you need to be prepared to use paper 2 concepts in paper 1. It doesn't happen a lot, okay? So please don't like stress that like paper 1 is basically going to be paper 2. It isn't. This is probably the only paper 2 concept that's going to be brought into this paper. But don't forget about those basics. And this is just a basic knowledge thing. Like, it's not like an obscure, weird question in terms of paper 2 knowledge or paper 2 content. It's straightforward. All right. So I'm just going to wait here for you guys to screenshot. And then we'll have a look at the last 2 in this question. All right, so last 2 questions, same. Is the straight line, it's actually just make our lives a little easier here. I'm just going to move them over to the side so we can still see what's happening. Right, so 4.6 says, is the straight line determined in question 4.5 a tangent to F? Explain your answer. Right, can someone tell me if it is a tangent?
No, it wouldn't be a tangent. I don't.
Why not, Putle?
It literally intersects the graph itself. It should be literally on the edge of it if it was a tangent.
Okay, good. So remember, a tangent line intersects with your graph once. So for example, a tangent line would not be that, but give me a second, would be something like that. It's only passing through the coordinate of D. That's it. We can see from our straight lines equation, I haven't drawn it very well on my graph above, but we can see from our straight lines equation, it obviously goes through coordinate C. We were told it goes through coordinate C. And it has a y-intercept at -3, which is actually D's coordinate. So that straight line, and I'm actually going to take the pink line off and redraw it. That straight line that we've just worked out in 4.5, is this pink straight line over here. Goodness gracious. And because it's passing through 2 points that are on my parabola, it cannot be a tangent. It must only pass through once. So it's not a tangent because it passes through both C and D. If it only passed through one of those points, it then potentially is a tangent to our curve. Right, so obviously you're getting a mark for no and a mark for your reason because it specifically said explain your answer. Right, 4.7, the last question of our functions question, is often one that stumps us a little bit, but again, it's about reading carefully and with comprehension. So 4.7 says the function h of x, which is f of m minus x plus q, has only one x-intercept at x equals 0. Determine the values of m and q. Right, so again, we're not going to panic. We're going to break this down. I'm just going to take all my scribbles off. I'm going to leave the coordinates that I know exist. And that's what we have. So, oops. F of m minus x plus q. Now, the second something is happening to m, as Callan said earlier, this is a vertical shift. Okay? It means that it's potentially shifting left or right. And we know that the second that we have a plus q, minus q, whatever, this is a horizontal shift. Obviously, I've now mixed up the 2 directions because why on earth would I know the difference between horizontal and vertical? So let's try that again. If something happens to x, we're shifting along the x-axis. That is a horizontal shift. And if we have a plus or minus q, that's an up or down shift. So that is a vertical shift. So immediately I know I need to consider these 2 transformations of my function. It's relating to f. Okay, so we're talking specifically about the parabola. I can ignore the hyperbola right now. And it's telling me that it only has one x-intercept at x equals 0. Now, guys, what that means is that my graph is going to sit something like that. Not my best parabola I've ever drawn, but it's going to something like that with an x-intercept and its only x-intercept at the origin, 0, 0, x equals 0. So now I need to figure out how am I shifting this graph to go from my original parabola to the graph that I've just drawn. And once we understand what the general equation is saying to us, and once we understand what type of graph or what graph it is that we're looking at, this actually becomes very, very easy. Okay, the only thing we do now need to bear in mind is if we go back to our situation over here, usually our bracket looks like what we had in our completing the square. So if I just look there, it's an x plus or minus p. In this case, I've got an m plus or minus x. So that's a bit of a weird one. Usually we want x plus or minus a value, and I'm just going to use m to keep it consistent here. But now it's swapped. So what we need to bear in mind is that that actually means that my x value has been times by a -1. Remember, if we swap terms, we're timesing by a -1. If x is multiplied by a negative, what this means is we have reflected, yeah, okay, in or over the y-axis. Okay, so that's just something that we need to bear in mind, that there's a reflection, and then we need to get this graph looking the way it is. I'm going to take this red graph off just so that we can now apply our transformations. So if I take the graph as I currently have it and I reflect it over my y-axis, I'm going to get something terrible. Oh no, oh no. I'm going to get something that looks like that. Okay, pretend that red graph is the best parabola that you have ever seen. That is a reflection over my y-axis. I've literally taken the parabola and I've flipped it over. What that means is that my turning point is now at +1, -4. And this x-intercept here would now be at -1, 0. We don't know where the other one is. We could work it out, but we don't really care right now. So there is my horizontal flip. And then again, what I need is a situation where I've got my parabola to be at x equals 0. So now we just figure it out. I definitely need to move my graph up. There's no option in that. I have to get it onto my x-axis. So I definitely have to move it up 4 units. Once it's up 4 units, I'm sitting over here. That's not where I want it. I need to shift this graph a further 1 unit to the left in order to get it onto my origin. So there's the little English, there's a reflection in the y-axis, and then we shifted 4 units up and we shifted 1 unit to the left. So we need our values of m and q. That's what the question was asking us to do. Now q is probably going to be a little bit easier to determine, so I'm going to start with q just because that's just my shift. 4 units up, and so q is equal to +4. It must go 4 units up. Now m needs to help me, or needs to eventually represent 1 unit to the left. Right, so if we have f of, and I'm not going to write the plus q, m minus x, I know that's the wrong order. So I'm immediately going to bring out the negative or times it by -1 to swap my order to be correct. And remember, this negative just represents that reflection. So now if I want to represent a shift to the left, I know that a shift to the left must mean that this bracket says x plus 1, which means that m has to be -1, so that when I substitute it in, the negative and the negative make +1, a shift 1 unit to the left. Now this is a 4 marker. This is chunky. Okay, Sunday, I will now. This is a chunky question. Okay, you have to understand the reflection and you have to understand your transformation. All right, let's go again. Okay, we have all that information. You have it written down. It's fine. So we have got h of x is equal to f of m minus x, has 1 x-intercept at x equals 0. And we want to find the values of m and q. So first we analyze our equation. Okay, so I'm taking this equation and I'm analyzing what's happening. the m minus x. So let's just start with that. F of m minus x. I don't like that. It is usually f of x plus or minus a value. Okay, it's usually f of x plus or minus p. So my order is wrong. So what that means is I need to take out a negative or times it by a -1 to swap my order around. Now remember, whenever you times the x value by a negative, okay, so what we're doing here is we're taking our x value and we're timesing it by a -1. That implies a reflection over my y-axis. So if I take this parabola and I reflect it over my y-axis, I'm going to get something like that. Obviously, this is not perfect, but it's going to be something like that. When my turning point C is now at +1, -4. So I've dealt with sorting out my order. The next thing I need to sort out is the fact that, according to my bracket, I'm clearly shifting left or right, so that horizontal shift, and I'm clearly shifting up or down. Now I need to figure out how much I'm shifting up or down and left and right. And this is now where we go to our next bit of information that says there's only one x-intercept at x equals 0. And what you need to remember is that if there's only one x-intercept, it means that your parabola is sitting on the x-axis. So the turning point is on the x-axis. And so that therefore means that this parabola must now sit over there at 0. So now I have to ask myself, how do I go from the red graph where I've dealt with the reflection to get to the pink graph? Well, to do that, I have to go 4 units up to make this parabola sit on my x-axis. So 4 up, which makes Q equal to +4. And I have to go 1 unit to the left because I already know, obviously I haven't drawn this very much to scale, but I already know that this x value at my turning point is at 1. So to get it to the origin, I have to go 1 unit to the left. So 1 left. And now I go and look at my bracket. If I wanted to represent 1 unit to the left, so 1 to the left, I know that that bracket should read x plus 1, because remember it's counterintuitive. X plus 1 means 1 unit to the left. For this to be x plus 1, if I'm currently sitting at x minus m, that m value would have to be -1, because when I substitute it in, x minus -1 gives me x plus 1, the shift 1 unit to the left. And so Q is 4 units up, M is 1 unit to the left, and I have considered the fact that there is actually that reflection. In my opinion, this is a 4 or nothing mark. If you don't see the fact that that bracket should be x minus m rather than m minus x, and you don't see that reflection, you're not going to get the rest of it. Okay, you're not going to see, you might get the Q value, the shift 4 units up, you'll get that, but then in your mind, you're actually shifting to the right when you should be shifting to the left. Asante, did that make more sense? Oh, sorry, I asked that and then I can't see any reactions, my bad. Does that make more sense? Just give me a thumbs up if you gave me one or not.
Ma'am, so the point of this question is to make sure that the x-intercept is 0 along with the y. So both of them must be 0. That's it.
Exactly.
Okay.
Yeah, pretty much. But like I say, the key here was recognizing that because it was m minus x rather than x minus m, there was that reflection of the y-axis. Because if you didn't reflect it, all you would be doing is going 1 up, 1 right. But we actually need to go 1 up, 1 left because of the reflection.
So the expression that they give us is going to tell us what we need to do.
Yes, exactly.
Okay.
Exactly. So this is a transformation question. This is a move your graph 1 up, 2 down, reflected, whatever. But like Bootcamp just said, it is understanding that h of x expression, f of m minus x plus q, is telling you exactly what transformations need to happen. Okay, sorry, Asante, does it make sense? I don't see any reaction just because I was being silly. Just let me know. Okay, I'm going to assume you're fine unless you say otherwise. It was Boutle. I'm leaving my school. My matrix gave it to me as a goodbye gift. Okay, let's screenshot the last few. I know they're very sweet. My little pumpkins. I think they're all banded together. Okay, I'm hoping we've got screenshots. Awesome. Boutle had us distracted there for a second. All right, guys. So the next type of question that you're going to get in your exam is the inverse function. All right. Now, inverse functions is not a lot of the marks. So of the 35 marks, this was 4, 8. This was actually quite a chunky one. I was saying that 12. This was 16 marks, but usually it's between like 10 to 12 marks, the inverse function question. And like I say, not super chunky. I would say maybe like 60% is grade 11 parabolas, hyperbolas, just normal, straightforward functions. But let's have a look. So it says sketch below is a graph of f of x, which is equal to k to the power x, where k is greater than 0. Now, this is important because this determines the shape of our graph. Obviously, we've got the graph in front of us, so we can clearly see that k has to be greater than 0. But remember, if k was a fraction, that would mean my graph is decreasing from left to right, and that would then change significantly the type of graph it is I'm working with. Right, it also tells us that the point 416 lies on our graph. And importantly, again, sometimes there's information on the graph that is not in the question and vice versa. We have also been given that the y-intercept is at 1. Now, we do kind of know that already because we know that exponential functions that haven't shifted up or down have a y-intercept at 1, that it is there and it hasn't necessarily been written out for us. So the first question says, determine the value of k. So I'm going to give you 2 minutes. It's 2 marks. I'm going to give you 2 minutes. Find the value of k for me. Nice, guys. Okay, so straightforward, we're just substituting in. So because we have f of x is equal to k to the power x, we're going to substitute in the coordinate that we know is on our graph, which is going to be the 416. We are not going to substitute in the y-intercept because remember, you would be substituting in x equals 0. If you substitute x equals 0 here, you'd have k to the power 0, which essentially cancels out the k because that would be 1. So we substitute in the 416. 16 is equal to k to the power 4. We ask ourselves, what value raised to the power 4 is equal to 16? Well, 2 to the power 4 is equal to 16, and so k is equal to 2. Alternatively, you could fourth root both sides and you would get the same answer. It doesn't really matter. Just bear in mind that whenever you take the even root of a value, so if you are going to fourth root, you would end up with plus or minus 2 is equal to k. But because of that restriction we were given over there, we know it is positive 2. Okay, so nice and easy, straightforward. You're getting a mark for sub and you're getting a mark for the answer of k. So if we have a look at question 5.2, it says graph G is obtained by reflecting the graph of f about the line y equals x. Remember, when we reflect about the line y equals x, we are looking at inverse function, and that's really important. That is how you spell inverse, yes. Right, so we're looking at the inverse function. We want to determine the equation of G in the form y equals. So this is where we already know f of x is equal to 2 to the power x. Anytime we are reflecting or finding the inverse, we swap. Okay, so we're going to swap our x and y. X is equal to 2 to the power y. And because this is an exponential equation, we now need to bring in logs. So y is equal to log 2x, and it asked us in the form y equals, and so that's it. Yes, please don't forget, y equals x means inverse. We are reflecting over the line y equals x, which I will attempt to draw for you. It's not going to be very good, but we'll just pretend. Okay, y equals x, and so we'd be getting the inverse logarithmic function, which would look something like that, with now an x-intercept at 1, 0, and that coordinate 416 would swap to now be 16, 4. Again, obviously not very much to scale, but that's kind of what it would look like. So look at that, 5.3, sketch a graph of G. I've done that already. It's beautiful. As long as you've got those two coordinates and you swap them, again, because it's that inverse, it's swapping x and y, we're good. And remember that the inverse has its asymptote swapping as well. So right now the exponential has an asymptote at the x-axis. Because it now swaps, my asymptote is the y-axis. So it won't actually cross that y-axis at all. So there's my sketch. 4 marks, okay. Usually our sketches are between, I would say, 3 and 4 marks. 4 is definitely on the heavier side when it comes to sketches of our functions. But we're sketching because those also aren't the words I wanted to use. We're getting 4 marks because we need to clearly see that you haven't cut the y-axis so that you know the y-axis is an asymptote. The correct shape of a logarithmic function, so you have actually reflected over that line. And then those 2 points, because it says indicate on your graph the coordinates of 2 points. So you've got the x-intercept, and then you have that 16, 4 point. Those are your 4 marks for the sketch. Right, if we look at 5.4, it's now those inequality questions. And again, these are not hard, but we do need to understand what's happening, obviously. So the first one says f of x times g of x greater than 0. So it's asking for a positive product. The only way for me to get a positive product is if I say a positive times a positive and a negative times a negative. That's the only way for me to get a value greater than 0 if it's a product. Okay. Now let's have a look at our graphs. My graph of f is only positive. Okay, so remember when we're talking about positive and negative, I'm talking about my y values. My f graph is only positive. My g graph, however, does have a negative portion, but it does also have a positive portion. And just because of the fact that I can't have a negative times a positive, I know that I'm only going to consider this positive portion of my g graph being multiplied with the positive portion of my f graph. Now, it's not great. I'm fully aware of the fact that I can't really draw a straight line. But basically, I want everything to the right of this line. Because if I go to the left of this line, I'm now dealing with a negative. I don't want that. I don't want the negative part of my graph. I only want the positive, and I want everything to the right because this also includes now the positive part of my f graph. Now, that x value is 1. So it's all x values greater than positive 1. And that's it. Okay, now this is an all or nothing mark. If that inequality is wrong, if it's going the wrong way, if you've included it in equals, you're getting 0, 2 or nothing. Okay, now I said this to you before, and I said it a while ago in functions. Oftentimes these inequality questions rely on intersections. So intersection with the x-axis, intersections between graphs, often the x values are going to relate to those. So sometimes it is useful to identify any points of intersection, x-intercepts, etc., because that will help guide you with your inequality. Is everyone fine with this first inequality? Awesome. Okay, cool.
Sorry, ma'am, please just re-explain. My connection wasn't very good there. So ma'am was
okay, sure.
Yeah.
So because we're looking for a positive product or product greater than 0, we're looking for either where the two graphs are positive or where the two graphs are negative. So when we talk about positive and negative, we're talking about y values. So everything above the x-axis is positive, anything below is negative. The whole graph of f is positive, but the graph of g is only positive from the x value of 1 to the right. Okay, below that it is negative. which means that if I take all of my values of y to the right of x equals 1, I'm looking at this green highlighted part, all of them are positive. And if I then times that by f of x, we already know all of them are positive anyways. So we would have a positive times a positive, and that gives me an inequality or a value greater than 0. And so it's all of the x values to the right of that x-intercept, which is positive 1. So x greater than 1 gives me all of those positive values on both functions. Make sense?
Yes, ma'am.
Cool. So guys, just as a sort of side note, sometimes we ask this as a quotient. So sometimes we would say f of x over g of x greater than 0. It means the same thing. Remember, the only way for you to get a positive or a negative fraction would be to consider the signs. So if we want to get a fraction that is positive, it has to be positive divided by positive or negative divided by negative. It's the same thing. So my answer would be exactly the same here. But if we look at 5.2, we're asking specifically g of x. Excuse me. Specifically g of x. And where is it less than equal to negative 1? Okay, so we are looking or considering a value of g of x, which is y. And so essentially, where is y less than equal to negative 1? Again, it's not going to be my best. So here's negative 1 on my y-axis. What x value does that correspond to? So I would need to actually go and determine what the corresponding x value is in this case. And this is just through substitution. All right, so, okay. Sorry, my brain has gone mushy. Negative 1 is equal to log base 2x. We could convert that back to an exponential if we want. So, x is equal to 2 to the negative 1, and so x is equal to a half. And I would convert it back to an exponential because obviously solving for logs, no, let's not do that. So the corresponding x value is a half. Now we want where it is less than equal to negative 1. So I want all of these values below, and that would be all of my x values to the left of that x. Now we need to remember that there's an asymptote here. So it's only in this little section where I'm going to find my y values less than 1. So it's between 0 and a half. Because I've included negative 1, I'm going to include the half, but I'm not going to include the 0 because remember, that is an asymptote. And so we can't include it because the graph doesn't actually exist there. And so as long as x is between 0 and a half, we will have all of the y values less than that negative 1 that we wanted. Right, again, does that make sense? This one was slightly more complex. Awesome. Okay, great. So guys, like you can see, the inverse is really not hard. Okay, it's the basics that we forget. So like Butler commented there, forgetting that y equals x is actually the inverse. Forgetting to swap x's and y's. Forgetting that the inverse of an exponential is actually a logarithmic and that you can convert between the two of them. So very straightforward questions. But like I said, it's just forgetting those little things that we just, I don't want to say forget to revise, but those little things that just kind of slip our mind. Right, I'm hoping we've got screenshots. Okay. So like I say, the other sort of big section in our paper is sequences and series. We've done the algebra, that's the next biggest section, but equal to that is sequences and series. And this is again a section where we should be doing well. Okay, there's no excuse not to do well with this. I know that sigma is maybe the one part that confuses us, but no. But realistically, sequences and series, we should be getting minimum 20 out of 25. That just moved by itself, so I don't feel great about what just happened there, but it's all right. Okay, so relatively recent final question paper. We've been given the arithmetic series 7 plus 12 plus 17. I want the value of term 91. I want the sum of 91 terms, and then we want the value of n for which t of n is equal to 517. That is a total of 8 marks. I'm giving you 8 minutes to answer those 3 questions. Let's go. I feel like I said that aggressively. Obviously, if you have questions, please ask, okay? But you have got 8 minutes to answer those questions. And please remember, think about what T of n represents and what S of n represents. Don't use the wrong formula because we've forgotten. And again, if you have questions, please ask. Nice. If you are done, you can just give me a thumbs up because I don't want to sit here wasting your time. So Callum Bouclier, see you. Doing nice. Sunday nice. Okay, I'm going to give 2 more minutes just for the rest of you to finish up and then we'll have a look. Angry tells this is kind of where and if you're busy, you can just ignore me. This is kind of where the discussion around time management that we had last weekend is so important. These are the questions that you should be identifying yourself and with English. Like we explained, you break your paper up into hours. In the first half an hour of your hour, you're doing these questions that you can do like this. Because even though this is 8 marks and should take you 8 minutes, some of you did that in 5. You're saving yourself 3 minutes that you can then spend on a complex question, a problem-solving question, on going back and checking your answers, etc., etc. And whilst I'm not saying work quickly, but do work efficiently. Okay, so these questions that you know you can get, great. All right, you do them quickly, they're done, and you move on. Alrighty, let's have a look. Now, obviously, just because, I'm a bit lazy and don't want to waste your time. There we go. All right, so it will get big in a second. There we go. First one, you have to find, you have to work with your TN formula. Now, grade 12s, obviously, it is up to you, but you have the formula on your formula sheet, and because you know that N is 91, you can actually just substitute everything in straight away. You know A is 7, you can see that the difference is the addition of 5 each time. You don't have to first work out TN and then substitute an N separately. You can do everything all at the same time. Obviously, if you do that, it's absolutely fine. You substitute in 91 for N and you get 500. No, you don't. You get 457. You can see the mark allocation there, getting your difference substitution answer. That's it. Right, 2 and 2, it's our sum formula. Again, you are given the sum formula on your formula sheet. Please don't try and memorize it. And please, guys, copy it down correctly. I know it seems silly, but make sure you're copying these things down properly. We want the sum of 91 terms. So again, N is 91. We know that A is 2. We know that, no, we don't know A is 2. We know A is 7. We know that we're working with the sum of 91, and we know the difference is 5. Sub it all in, get your sum of 21,112. When it comes to 2 and 3, calculate the value of N for which T of N is equal to 517. What's important to remember here is that if I give you T of N, I'm giving you the value of your term. So I'm telling you what to substitute T of N for. Now, because in the first question you had worked out Tn is equal to 5n plus 2, you can then just make that equal to 517 and solve for n, which is 103 in this case. Right, so we get 8 out of 8. Nice. Okay, so you have bagged 5% in your exam. Easy peasy. Now, just think about the fact that, again, we had this conversation that 55% of your marks are knowledge. Sorry, I'm just losing hair like a dog. Is knowledge and routine type of questions. You should be getting bare minimum 55% in your exam. Boucle, what happened?
Just 5%. Yo.
Oh, I thought you meant you just got 5. Yes, just 5%. But I mean, think of it in terms of that's the difference between your 35 and your 40, your 75 and your 80, etc., etc. It makes a difference. Okay, and obviously we're going to have lots of these little questions as we go along. All right, I'm just going to wait there in case you want to screenshot all of that, and then I'm going to move. Okay. All right, so 2.2, the following information is given about a quadratic number pattern. So before I even carry on, what is a quadratic number pattern? What defines it? So in arithmetic, constant difference. Okay, Bootley, it looks like a trinomial. Okay, cool. So we're following a trinomial thing, an squared plus bn plus c. How would I be able to identify? So for example, arithmetic, I saw I was adding 5 each time. How would I be able to identify a quadratic?
It has a first and a second difference.
Okay, and what's special about the second difference?
It's always constant. It's an arithmetic, basically.
Good, good. Okay, so importantly, guys, there's a constant second difference. And what Bootley has said there is actually quite useful to us sometimes. If you go and work out your first differences, they form an arithmetic pattern, and that's often very helpful for us in certain questions. Okay, so we've been given the information about a quadratic number pattern. Term 1 is equal to 3, term 2 minus term 1 is equal to 9, and term 3 minus term 2 is equal to 21. Now, I struggle to understand visually what that all represents if I don't write it out for myself. Okay, so I'm going to form a little pattern here for myself, and I'm just going to fill in what I know. Sorry, got distracted by myself. Term 1 is 3, so that's 3. Term 1 of my pattern. 1, 2, 3, 4. If I take term 2 and I subtract term 1, I get 9. So that is my first difference that I've worked out. And if I take term 3 and I minus term 2, I get 21. So whilst I don't have information about the rest of my quadratic sequence or the rest of my first differences, I do have enough to help me answer my questions. And that's because I was told specifically it is a quadratic number pattern, which means that I know I have a constant second difference. Now, if I know I have a constant second difference, I can go and work that out. So if I go and work out the difference between 21 and 9, I get something, 12. 12. Okay, so my difference is 12. So that means every single time my second difference is 12. And I would keep adding 12, etc., etc. So through what I have, I know my second difference is equal to 21 minus 9, which is 12. And so now I can work out my next differences. So basically, if I now go and work out my third first difference, if I add 12 to 21, I get 33. And this now helps me get my next few terms, because if I follow my differences, 3 plus 9 is 12. Second term. 12 plus 21, 33. Third term. 33 plus 33, 66. Fourth term. If I now add another 12 to 33 to get my next difference, that's an addition of 45. I can get term 5. So if I add 45, I get 109. And so I get, can I not do math? I can't do math. It's 111 because 6 plus 5 is 11. So sorry. 111. So just by kind of reverse engineering, I can get that term 5 is equal to 111. And guys, having this working out, even though it's not like mathematical, that is worth something, okay? If I can see that you've gone back and found those differences, that's marks. If I can see that you've gone and found your terms, that's marks. Having that second difference, marks. So a 2-mark question, but it's just reverse engineering the information that we've already been given. So in terms of the mark allocation here, you would have gotten a mark for your constant second difference of 12. And like I say, a mark for getting those first differences of 33 and 45. And like I say, just showing it like this with just like the bunny hops and stuff, that's 2 marks. It doesn't have to be like presented beautifully. Does that make sense for everyone? Because like I say, not a hard question, but it is a bit of sort of having to work backwards. So it's important that we do understand how to do that. Awesome. Right, so 2.2.2 says show that the general term of the quadratic is 6n squared minus 9n plus 6. Again, says show that. You may not use that. You just need to go and work out the general term. Do we all remember how to do that for a quadratic? Okay, 1 yes, 2 yeses, 3 yeses. Right, so remember it's those 3 equations. Second difference equals 2a. 3a plus b, first difference, etc., etc. 3 marks, I'm giving you 3 minutes. Let's work out the general term. And obviously, guys, because it's a show that question, you do actually know what the general term is. You just have to show that it's correct. So you can let me know whether or not you agree with it, that it is 6n squared minus 9n plus 6. Okay, just give me a thumbs up when we're done. So, Callan, Butle, Sunday, I see you. Do have 1 more minute, but just give me a thumbs up if you are. Okay. Yeah, just because I'm lazy. It'll arrive. Maybe it won't arrive. Okay, so 2a equals 12, so you got a equals 6. Substitute that in, you get a, b, and c. I've obviously made this too big, but that's okay because, whatever. All right, so that's it. You are obviously not getting a final mark for 6n squared minus 9n plus 6. As I explained earlier, I gave that to you. I'm not going to give you marks for something I gave. But you are going to get marks for all of your working out leading up to that. All right, and that's it. When we get to this last question again, this is not a hard question, but we panic because how do I put this? We forget that we have knowledge, okay? And I know that sounds like a really stupid statement, but this is easy. This is a maximum minimum question. So it says, show that the pattern is increasing for all values of n is a natural number. So let's just discuss what that means. A, show that the pattern is increasing. So basically show that the pattern just keeps getting bigger and bigger and bigger and bigger. That my values keep increasing. Right? Now, even though it's a parabola, remember that if we consider a parabolic function, there's a part that decreases and the part that increases. Even if it was negative, but we know it's not negative because it's positive 6n squared. But because we're talking about the natural numbers, we know that we could potentially, if we look at our parabola, only be looking at natural numbers, say, for example, from term 1, term 2, term 3, term 4. And we're only considering this part of the graph where it is increasing. So when we talk about natural numbers, we're referring to the fact that this is a sequence, and we are not looking at n equals -3 2/4 or +7 4/8. We know that n can only be a natural number, 1, 2, 3, 4, etc., etc. All right, so what does that mean? What are we trying to determine here? Now, there's, again, 2 ways to do this, and this is what I'm saying. Don't forget that you have it in your brain. So option 1 is you can work out, excuse me, you can go and work out where your turning point would exist, because hopefully you agree with me that if we can prove that this turning point is positive, so greater than 0, it means that all of these values are increasing. If you don't want to use your turning point, obviously we know we could use our derivative. So if we can find our first derivative and show that when it's equal to 0, it is positive, once again, what we are showing is that from the point, the stationary point, the turning point, if it is greater than 0, we're talking about the increasing portion of my graph. So like I said, this is just a basic maximum, minimum, increasing, decreasing question, but we're just now putting it into our sequences and series question. So like I said, there's 2 options. Option 1 is to work with the derivative. So I don't even know how we would write this. T prime n, derivative in terms of n. So it's not great, but yeah. Is 12n minus 9. And we would make that equal to 0 is equal to, so if it's equal to 0, remember that's a turning point. So if we can show that this is positive, we're on the right track. 12n is equal to +9, n is equal to 9 over 12, which is 3 over 4. And so because my turning point is in relation to my x-axis at a positive value, it means that everything greater than this value, so any value greater than 3 over 4, is increasing. Now, again, because it's natural numbers, my first natural number after this is 1, 2, 3. So my first term is positive, then it's just increasing from there on out. If you don't want to use derivative, you don't have to. You can use a turning point formula. So the x value of our turning point is equal to minus b over 2a. B, we're going back to our Tn formula, is -9 over 2a, so 2 times 6. And we get exactly the same value, 3 over 4. And so because we have our minimum, our turning point at 3 over 4, we know that the first natural number here would be 1. And so that would be the smallest value for our sequence, because n equals 1, first term. And we can see that it thereafter increases, because everything after that 3/4 is my increasing part of my function. Okay, so guys, this would be considered a complex question if we sort of go back to those question levels: knowledge, routine, complex problem solving. This would be considered a complex question. They might even classify it as problem solving, but it's not hard. And this is the most important thing when it comes to these types of questions. You need to remember that you do actually know what to do. It's just a case of absorbing that knowledge. What's up?
Ma'am, so because it's increasing for all what is it?
Natural
values, natural numbers. So that's why we say n is greater than 3 over 4.
Exactly. So what we have determined is that if I were to draw this parabola, its turning point in terms of x is at 3 over 4. But obviously we know, because this is a sequence, 3 over 4 is not a value for n. My n values are 1, 2, 3, 4. So the next value thereafter, if I now go along my graph, is all going to be the increasing values. And so because it is turning point 3 over 4 and everything to the right is increasing, 1, 2, 3, 4, every value is then increasing for my natural numbers. That makes sense?
Oh, so it's all about what's on which either side of the turning point, basically.
Exactly, exactly.
If it was decreasing for all natural numbers, then it would have been smaller than 3 over 4.
Okay. Exactly. So if this had been a negative, so let's say it had been Tn equals -6n squared, so then it would be a sad parabola. So if we said show that the pattern is decreasing for all natural numbers, if we got our turning point, and let's say it was still even at, I was going somewhere with that statement and then my brain went, let's say it was still 3 over 4. I know that my next natural number there is 1, and then I would keep going 1, 2, 3, 4, but those are all decreasing now. Okay, so guys, what I want you to remember, and it happens particularly with quadratics, okay, we often like to show that the pattern is increasing. Even last year's question was, I think it was actually almost the same question. It was also show that the pattern is increasing or is positive for all values of n. Just think of it in terms of your turning point. If you can show that your turning point is positive and then they are on greater, it's increasing. Right, I'm just going to wait there for you to screenshot. Right, and then I'm going to give you an option, and it is entirely up to you. I'm not going to be offended if you want to go. Sorry, I heard someone unmute. We all good?
Ma'am, what do you use an app on your computer to screenshot?
I think it's built in. So if you say, oh, now you're asking me the questions. Okay. So, basically on your keyboard, right? If you go this like Windows Home button and you hold that with the Shift and the S all together, it allows you to screenshot. Otherwise, what you can do is if you just say print screen, it takes a picture of the screen and then you can just copy that into a Word document.
It worked.
Yeah, so once you've taken that screenshot, you then just, again, Control V, paste it into whatever document it is you're working with, and then you've got all the screenshots there. I'm glad I could teach the youth something about technology. Okay, guys, so you may decide, it is entirely up to you. We've got one more question on sequences and series, and it is a Sigma question. So it's 5 marks, so it shouldn't take us longer than like 10 minutes. So we should be done by 20:15. If you need to leave and if you want to leave, that's absolutely fine. I'm not going to hold it against you. I know we are past 4 o'clock, but I am going to do this last question for those of you that do want to stay and just have a look, because like I say, I know that Sigma is sometimes the one that scares us the most. But if you do want to leave, that's absolutely fine. Like I say, I'm not going to hold it against you. And I'll see you next week for our last boot camp on paper 2, where, like I said earlier, we're going to focus very much on trig and Euclidean, and very much grade 11 Euclidean on circles. All right, so for those of you that are staying, I'm just going to go. If you leave, you leave. And like I say, have a lovely rest of the weekend. We are given the geometric series 3 + 6 + 12 to n terms. Okay, so that means it's going to keep going to a certain number. Now, what I always like to do is I like to figure out my A value, figure out my R value, or my D value, or my second difference, or whatever it is concerning the sequence. Sunday, I am sharing the screen, the screen. Let me just stop and reshare it. Just let me know if you can see it now. Can you see it? Okay, I'll wait for you because I don't want you to miss out, so I'll wait. Also lied, I said it's 5 marks. It's not, I think it's 8 marks because there's another question that I seem to have forgotten to put on here. That's weird. Huh. Okay, we're just going to do this. It was just a sum question. It wasn't hard, so it's fine. I want to focus on the sigma. Okay, I'm going to start. Sunday will join just because I'm going to do the basics here. So we know that if we are working with geometric, Tn is A times R to the power n minus 1. If we're looking at the sum of a geometric, I'm sorry if you can hear a child screaming. It's chaos, and there's dogs barking now. This is a times 1 minus r to the power n over 1 minus r, or you can say a times r to the power n minus 1 over r minus 1. This is the one on your formula sheet, but they're both exactly the same thing. Use what you want. I always use the second one. I don't know why I chose to write the first one first, because I never actually use it. Makes no difference. Okay, Sunday, let me know if you can see it. Right, so I need a first term, and then I need r. So r is going to be term 2 divided by term 1, which is 2. Awesome. Okay, so now I have my information and I can go and do things. So it says write down the general term of the series. Well, look at that. I have everything I need. Tn is equal to a, which is 3 times 2 to the power n minus 1. That's it. 1 mark, done, dusted, easy peasy. But then it throws us into the deep end. It says calculate the value of k such that k over, no, let's try that again. The sum of terms 1 to k of the sequence 3 over 2 times 2 to the power p equals 98,301. Now, guys, this is actually the same sequence that we're working with. I don't necessarily want you to stress about needing to understand why it is the same. I'm going to show you why it's the same series. But remember, we have got steps that we follow to work out an unknown. So just that you can see it is actually the same thing. 3 over 2 is 3 times 2 to the negative 1. Remember, it's a fraction, so I could write it as a negative exponent. And then we've got times 2 to the p. Now, because those are the same base, I can add those exponents together. 3 times 2 to the power p minus 1. It's exactly the same as what I just wrote down for my Tn. So it's exactly the same. I'm working with 3 plus 12 plus 6, blah, 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 blah. Okay, but if we don't see that, it doesn't matter. It's not the end of the world. That's not important. I just want you to see that sometimes we do change the way things are written, but it still represents the same thing. We know that when we get to sigma questions, the first thing that we always do is work out the first 3 terms. So I'm going to substitute p equals 1, p equals 2, and p equals 3 into this Tn formula. Now, you can use the Tn you've just worked out, but I wouldn't. I would just use the one that was given to you just to avoid any silly mistakes. We're going to substitute that in there. So 3 over 2 times 2 to the power 1. 3 over 2 times 2 to the power 2, blah, 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 blah. And we're going to work out the sum of our first 3 terms. So we're going to get to term 1, term 2, and term 3. That is the first thing that you always do. That is generally a mark allocated. I'm pretty sure I have sigma on this calculator, but let's not stress ourselves. So the first term, 3, we actually already know that. Second term, we're just going to double check, should be 6. It is 6. And then the third term, obviously, 12. So we actually have this information ready, and that's because, like I already showed you, it is the same sequence above. So we've worked out the first 3 terms. What we then want to do is we want to work out what sigma formula am I working with. Now, because this is not a sum to infinity, this is a diverging geometric series, I'm going to use a formula that I wrote up there. So the sum of n terms is equal to a times r to the power n minus 1 all over r minus 1. Now, remember, we're trying to figure out k, and k is the top number. So k tells us the last term that we're going to add. So I don't actually know how many terms I'm adding. That's what I'm trying to work out. But I know I'm starting from the first term. So the sum of n terms, we know, is the 98,300. So I can substitute that in for S of n. 98,301 is equal to A is my first term, so 3. R is 2, so 2 to the power n minus 1, all over 2 minus 1, which is just 1. So what I have is an equation of 98,301 is equal to 3 times 2 to the power n minus 1. And now I just solve my equation. So I'm going to divide both sides by that coefficient of 3, giving me 32,767 is equal to 2 to the power n minus 1. And then I'm going to add 1 on both sides. So 32,768 is equal to 2 to the power n. And now if you want to convert it to a log, you can. I don't. Like, my first choice is not to convert to a log. I would just use my calculator and type in 32,768 equals shift fact to get the prime factors. And I get that 2 to the power 15 is equal to 2 to the power n. And so n is equal to 15. Now remember, this isn't necessary in this case, but I'm going to show you it because if we don't start adding from the first term, this number that you have found just tells you how many terms you're adding. It doesn't give you the top number, which is the last term that you added. So if you want the number of terms that you are adding, we will take the top number minus the bottom number plus 1. And I remember I said to you guys in class, this is a very useful little formula to have. Now we know the number of terms we're adding. We've just worked it out. It's 15. The top number is k. That's what I'm trying to determine. My bottom number is 1, and then I add 1. And this is why I'm saying it's not actually necessary in this case, because this formula only is important if we start adding from a term that isn't 1, or from a term that isn't the first term, from a term that isn't the first. So if that p had been like p equals 3, then this would be important. Then I'd have to use this whole formula. But because p is 1, I don't care. And so we get that k is equal to 15. I'm adding 15 terms in order to get that sum of 98,301. So guys, sigma you need to break down. Step 1, work out the first 3 terms. Step 2, substitute into the appropriate sum formula. And you substitute in what you know. If you're given the sum, substitute that for S of n. You know A, you know R because you've just worked that out. Substitute into your sum formula, solve for your unknown. Only if that bottom number is not 1, do you then still need to go and use this little formula. Number of terms added equals top minus bottom plus 1. Okay, so that's only if we don't start with the first term, and then you solve for your unknown, and that's it. Okay, so sigma does not need to be scary, but we do need to understand what it means, and we need to break it down for ourselves.